in this problem we have a basketball being bounced, and the sound reaches these two microphones at the floor and at a distance 2.0 meters from the floor. Now we're told that the time difference is 1.30 milliseconds. So the time that it takes to reach the second microphone is 1.30 milliseconds longer than the time it takes to reach the first microphone. Now we're asked to find what the lengths are, L1 to the first microphone and L2 to the second microphone. We know that delta T, T2 minus T1, the time difference is 1.30 milliseconds. The velocity of sound is 343 meters per second, and the height of that second microphone is 2.00 meters. Now, to start off, we know that distance equals velocity times time. So we can say d equals vt. And our d in this case are the lengths. So what we can do is we can solve for the time and plug into this equation here, t2 minus t1 equals 1.30 milliseconds. So we'll be able to get something from that. So we have t equals distance divided by velocity. So in terms of our L1 and L2, we have T2 equals L2 divided by velocity, and T1 equals L1 divided by velocity. The velocity is the same because it's just the velocity of sound. So what we're going to do is plug these two into here, see what we get. So we have T2 minus T1 equals 1.30 milliseconds. So we'll plug in L2 over V. L2 over V minus L1 over V is 1.30 milliseconds. So instead of calling this 1.30 milliseconds, now I'm just going to leave it as delta T, because delta T equals So we'll leave it as delta T so it's easier to work with, and we'll just plug everything at the end. So we have L2 minus L1 over V equals delta T. L2 minus L1 over V is delta T, just by combining like terms. Now, we don't know L2, we don't know L1, we know V, we know delta T. We do know, however, a relationship between the two lengths, L2 and L1. We can use Pythagoras' theorem. We can say that a squared plus b squared equals c squared. So if we have a squared plus b squared equals c squared, and c squared is always a hypotenuse, so if we write this out, we have L1 squared plus the height squared, which we know, equals L2 squared. So what that's going to do is allow us to get an equation, L2, in terms of L1. So we can take this L2 and plug it in here. Or we can actually solve here and plug in here. Why don't we do that instead? So I'm going to solve for L2 is the easiest. So I multiply V over V delta T, and then that leaves me with L2 minus L1, so I add L1 over. So I have L2 is equal to this. I'm going to substitute this in for this L2 here. So I have L1 squared plus H squared equals L2 all squared. So it's V delta T plus L1 all squared. So now I basically have to simplify this out by squaring that through. So I have L1 squared plus H squared equals, I'll multiply that out so I get V squared delta T squared by doing the first term. The second term gives me L1 squared, and I get my cross terms 2V delta T L1. Okay, now of this I can do some canceling. I can subtract L1 from both sides. So I'm left with H squared, V squared, delta T squared, 2V delta T L1. Now let's look at what we do and do not know. We know height. We know V. We know delta T. We know V. We know delta T. The only thing we don't know is L1. So from this, we can actually figure out what L1 is. So I'm going to solve for L1. So that's going to leave me with h squared on this side. Subtract v squared delta t squared. Let's leave me with 2v delta t L1. So I divide everything by 2v delta t equals L1. Now, if you have to do that algebra in multiple steps, that's fine. I'm just doing it all in one here. So if I plug all these numbers in, L1 equals h of 2.00 meters squared minus our velocity of 343 meters per second squared times our delta t of 1.30 milliseconds. Now milliseconds is times 10 to the minus 3, and we want this in seconds, so I put in 1.3 times 1.30, so that's 0 significant, 1.30 times 10 to the minus 3, e times 10 to the minus 3 squared, all divided by 2 times our velocity of 343 meters per second times our delta t, 1.30 times 10 to the minus 3. Now, if I plug all this into my calculator, square this, subtract off that, and then all divide by that, you should get a length 1 of 4.26 meters. Okay? Now, to get L2, we plug back into either this formula, because we now know L1, or back into our Pythagoras theorem. And that's probably the easiest. We have L2 squared equals L1 squared plus h squared. L1 squared plus h squared. So we plug in L1 squared here. So we have L2 squared equals 4.26 meters squared plus our height of 2.00 meters squared. So add those up, then we have both sides, so we have to square root both sides. Get L2 as a value of 5.85 meters. So those are our final answers.